In this video, we're going to talk about our range of physical layer switches. These are physical layer switches. Most people, when they hear of a switch, will think of a network switch, which is a packet switch. In a packet switch, I can plug many devices into the ports and they will all talk to each other. A physical layer switch is like physically plugging and unplugging cables. So I connect port 1 to port A and it won't talk anywhere else. This is very helpful for test scenarios and for applications where you don't want the switch to interfere with your test. So it wants to be transparent. Andy, would you like to tell us a little bit more about them?
So this is a USB switch, USB pretty much everywhere. A common use case for this, for example, would be in a vehicle's infotainment system. So you have multiple different phones, you have multiple different USB sticks, perhaps with music on, different things that people will want to connect into their system at different times. We can connect up to 8 different devices in here. A single host port back into the car's infotainment system, and then you can automatically iterate through each device, plugging one, removing another one in sequence, testing all of them. You can get 8 times the amount of testing without any user intervention. There's more we can do with that though. You might have cases, for example, where you want to air gap certain security devices. So here I've got a global signing certificate that we use for our code signing. We can connect that to the host or remove it. So we can air gap it from the system completely and give a second factor of protection against critical devices. So Mike's already showed you the SATA switch. So this one has 4 host ports and 8 device ports. And standard use case for this, I've got some drives. So some of the other Quartz products you may have seen, we can automate removal and insertion of a single drive. But what if you want to switch drives over? We can have one host or up to 4 different hosts, and we can connect them into multiple different drives. Now, we're not actually providing power to the drive here, but the example is valid. We can now switch either of these 2 drives into our one host on command, and that can be either via serial or it can be via USB or LAN. So it's very simple to, for example, test multiple different devices in the host in sequence again, or it could be used for swapping over one device for another to aid with an automated backup process.
So the final product we have here is our Mini-SAS HD switch. This is used in commercial enterprise data storage systems, and it's a very typical interconnect. And a customer might want to use this to try different scenarios that are shipped to customers. So perhaps a product ships with 1, 2, 3, or 4 shelves beneath it. Well, rather than having to go back into a test and recable that system, we can plug everything into our switch here, and we can use a script to connect 1, 2, or 3 racks. And we can also create some basic faults as well. So we can drop lanes or we can switch lanes. Another interesting use case with this one is that we can copy lanes. And so we could plug a signal analyzer in and actually have a look at some of the data that's going past. Which is very useful.
You can also split the lanes out as well. So similar to the SATA switch, you can actually split SAS into 4 SATA lanes. So we plug one of these in here. This would actually allow you to connect up to 48 drives at the same time, although you would need to actually reserve one of them for a host. Mm-hmm. But there are many different cables available. I mean, we have ones that go straight into a drive with power. We have Mini-SAS HD to HD cables that would go from, as Mike said, between servers and a shelf of disks, for example. So this is great to put at the top of a rack and then automate your entire process.